We've been working on the antiderivative functions or the indefinite integral, and we have a list here of all our standard antiderivative functions. A couple things that we've highlighted though, the plus c, when we anti-differentiate, we have to always account for the plus c because we don't know if that c, when we differentiate, could have been differentiated to 0 in the derivative function. The other thing is this horizontal compression of k. Now, if you recall, when we differentiate k, the horizontal compression, we have to multiply by k to account for that. When we anti-differentiate the k, horizontal compression, we have to divide by k to account for that. One of the things that we want to be aware of is, and be careful of, is this 1 over x. Whenever we have 1 over x, it integrates to log absolute value of x. And the reason why the absolute value is there is because if we think of the original 1 over x function, the domain of that is positive and negative values of x. We have to be able to account for the original domain of the function in its antiderivative function, log. If we just left it as log, we would not be able to put the negative x values that we could have in here. We could not use them in the antiderivative function. So that's why that absolute value is there. The other thing here is the a to the x function. We have to remember that when we differentiate a non-base e exponential function, we need to multiply by log of that base to be able to account for the non-base e. So if we're multiplying when we differentiate, we need to divide by that log of base a, the log a, to account for the non-base e. Practicing some antiderivative functions, we have sine of 3x, the antiderivative of that, or the indefinite integral. The derivative of cos is negative sine, so the antiderivative of sine is going to be negative cos. So we're going to end up with y equals negative cosine, and there's a 3, a horizontal compression with the x. To account for that horizontal compression, we need to make sure that we divide by that 3. And we can't forget the plus c. The derivative of sine is cosine, so the antiderivative of cosine is going to be sine. So we end up with sine of 3x. And again, because of that horizontal compression, we're going to account for that by divide by 3. And don't forget the plus c. For the exponential function, the antiderivative is going to be itself. So I'm going to end up with 3 to the power x. However, because it's not a base e, we need to account for that non-base e by the dividing by log of the base, or log 3. And again, don't forget the plus c that we have to account for. In D, what we're going to do is just anti-differentiate term by term. We have y is equal to, we're going to increase the power by 1, so we end up with 2x to the power 5. We divide by that new power, so we divide by 5. Plus e to the 3x just becomes e to the 3x. It just regenerates itself. But because of that horizontal compression, we have to make sure we account for that with a divide by 3. The antiderivative of slope of 4 is just 4x, the linear function, and then we need to account for the plus c.